Question number 19. Question number 9. Worksheet work power energy. A lorry of mass 16,000 kg climbs from the bottom to the top of a straight hill of length 1000 meters at a constant speed of 10 meters per second. The top of the hill is 20 meters above the level of the bottom of the hill. So this is 20 meters. The driving force of the lorry is constant and is equals to 5,000 newtons. Find the gain in gravitational potential energy. So that would be mgh, mass being 16,000, g is 10, height is 20. This gives 3,200,000 joules. Part 2, work done by driving force. Now, the formula for work done by driving force is just driving force times distance if both these values are given. So 5,000 times 1,000. So driving force is 5 million joules. Okay. Part 3, work done against the force resisting the motion of the lorry. Okay. Now, since we don't have the resisting force value, so we can't use F times D to find the work done against resisting force. So instead, I'm going to use the energy formula that I know, the conservation of energy formula, which says work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. Okay. Work done by driving force was found in part 2, which was 5 million, plus energy loss. Okay. The kinetic energy will not change in the system because the speed is constant. So this will just be 0. And the potential energy has increased from bottom to the top. So it will be written over here towards the right hand side. Okay. Work done by resisting force would be X plus gain in energy was mgh, that was already found, 3,200,000. Okay, you make X the subject here. We get 1,800,000 joules. Okay, part 3 is done. On reaching the top of the hill, the lorry continues along a straight horizontal road against a constant resistance of 1,500 newtons. Okay, so now it continues on a straight horizontal road, and the lorry now faces resistance of 1,500 newtons. The driving force of the lorry is not now constant, and the speed of the lorry increases from 10 at the top of the hill to 25 at a point P. Okay, this is the top of the hill, there's a point P. And they've told us that the speed increases from 10 to 25, which means there's going to be a gain in kinetic energy. The distance of P from the top of the hill is 2,000 meters. So this length is 2,000 meters. Find the work done by driving force of the lorry while the lorry travels from the top of the hill to P. Okay, so we need the work done by driving force here. So again, I'm going to use the energy conservation formula. Work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. Work done by driving force is X plus loss in energy. Okay, so we know the kinetic energy is a gain, so we don't write it over here. And there's no gain in potential energy or no loss in potential energy in the horizontal region because the height difference is zero. So there's no loss in energy. We can just write zero or nothing at all. Work done by resisting force would be, we know the resisting force, which is 1500, and we know the distance. So work done is equals to FD. Work done by resisting force is equals to resisting force times distance. So that's going to be 1500 times 2000 plus gain in energy. That's the kinetic energy gain. So half times M, which is 16,000, times difference in speed squared. So bigger speed is 25 squared minus smaller speed is 10 squared. Solve this to get the value of x, which should give this as the final answer.